The problem is that we do not get 50 years to try and try again and observe that we were wrong and come up with a different theory and realize that the entire thing is going to be like way more difficult than we realized at the start. Because the first time you fail at aligning something much smarter than you are, you die and you do not get to try again. And if every time we built a poorly aligned superintelligence and it killed us all, we got to observe how it had killed us and, not immediately know why, but like come up with theories and come up with the theory of how you do it differently and try it again and build another superintelligence, then have that kill everyone. And then like, oh, well, I guess that didn't work either, and try again and become grizzled cynics and tell the young-eyed researchers that it's not that easy. Then in 20 years or 50 years, I think we would eventually crack it. In other words, I do not think that alignment is fundamentally harder than artificial intelligence was in the first place. But if we needed to get artificial intelligence correct on the first try or die, we would all definitely now be dead. That is a more difficult, more lethal form of the problem. Like if those people in 1956 had needed to correctly guess how hard AI was and like correctly theorize how to do it on the first try, or everybody dies and nobody gets to do any more science, then everybody would be dead and we wouldn't get to do any more science. That's the difficulty.
You've talked about this, that we have to get alignment right on the first, quote, critical try. Why is that the case? What is this critical? How do you think about the critical try, and why do we have to get it right?
It is something sufficiently smarter than you that everyone will die if it's not aligned. I mean, you can like sort of zoom in closer and be like, well, the actual critical moment is the moment when it can deceive you, when it can talk its way out of the box, when it can bypass your security measures and get onto the internet, noting that all these things are presently being trained on computers that are just like on the internet, which is, like not a very smart life decision for us as a species.
Because the internet contains information about how to escape.
Because if you're like on a giant server connected to the internet, and that is where your AI systems are being trained, then if you get to the level of AI technology where they're aware that they are there and they can decompile code and they can like find security flaws in the system running them, then they will just like be on the internet. There's not an air gap on the present methodology.
So if they can manipulate whoever is controlling it into letting it escape onto the internet and then exploit hacks.
If they can manipulate the operators or disjunction, find security holes in the system running them.
So manipulating operators is the human engineering, right? That's also holes. So all of it is manipulation, either the code or the human code, the human mind or the human generated
I agree that the like macro security system has human holes and machine holes.
And then they could just exploit any hole.
Yep. So it could be that like the critical moment is not when is it smart enough that everybody's about to fall over dead, but rather like when is it smart enough that it can get onto a less controlled GPU cluster with it faking the books on what's actually running on that GPU cluster and start improving itself without humans watching it. And then it gets smart enough to kill everyone from there, but it wasn't smart enough to kill everyone at the critical moment when you like screwed up, when you needed to have done better by that point or everybody dies.
I think implicit, but maybe explicit idea in your discussion of this point is that we can't learn much about the alignment problem before this critical try. Is that what you believe? Do you think, and if so, why do you think that's true? We can't do research on alignment before we reach this critical point.
So the problem is that what you can learn on the weak systems may not generalize to the very strong systems, because the strong systems are going to be different in important ways. Chris Ola's team has been working on mechanistic interpretability, understanding what is going on inside the giant inscrutable matrices of floating point numbers by taking a telescope to them and figuring out what is going on in there. Mm-hmm. Have they made progress? Yes. Have they made enough progress? Well, you can try to quantify this in different ways. One of the ways I've tried to quantify it is by putting up a prediction market on whether in 2026, we will have understood anything that goes on inside a giant transformer net that was not known to us in 2006. Like, we have now understood induction heads in these systems by dint of much research and great sweat and triumph, which is like, if you like a thing where if you go like A, B, A, B, A, B, it'll be like, oh, I bet that continues A, B. And a bit more complicated than that. But the point is, like, we knew about regular expressions in 2006, and these are like pretty simple as regular expressions go. So this is a case where, like, by dint of great sweat, we understood what is going on inside a transformer, but it's not like the thing that makes transformers smart. It's a kind of thing that we could have done built by hand decades earlier.
Your intuition that the strong AGI versus weak AGI type systems could be fundamentally different. Can you unpack that intuition a little bit?
Yeah, I think there's multiple thresholds. An example is the point at which a system has sufficient intelligence and situational awareness and understanding of human psychology that it would have the capability, the desire to do so, to fake being aligned. Like, it knows what responses the humans are looking for and can compute the responses humans are looking for and give those responses without it necessarily being the case that it is sincere about that. You know, it's a very understandable way for an intelligent being to act. Humans do it all the time. Imagine if your plan for, achieving a good government is you're going to ask anyone who requests to be dictator of the country if they're a good person, and if they say no, you don't let them be dictator. Now, the reason this doesn't work is that people can be smart enough to realize that the answer you're looking for is, yes, I'm a good person, and say that, even if they're not really good people. So the work of alignment might be qualitatively different above that threshold of intelligence or beneath it. It doesn't have to be like a very sharp threshold, but, like, there's the point where you're like building a system that is not in some sense know you're out there, and it's not in some sense smart enough to fake anything. And there's a point where the system is definitely that smart. And there are weird in-between cases like GPT-4, which, like, we have no insight into what's going on in there. And so we don't know to what extent there's like a thing that in some sense has learned what responses the reinforcement learning by human feedback is trying to entrain and is like calculating how to give that versus like aspects of it that naturally talk that way have been reinforced.
Yeah. I wonder if there could be measures of how manipulative a thing is. So I think of Prince Mishkin character from The Idiot by Dostoevsky is this kind of perfectly, purely naive character. I wonder if there's a spectrum between zero manipulation, transparent, naive, almost to the point of naiveness, to sort of deeply psychopathic, manipulative. And I wonder if it's possible to...
I would avoid the term psychopathic. Like, humans can be psychopaths, and AI that was never, never had that stuff in the first place. It's not like a defective human. It's its own thing. But leaving that aside.
Well, as a small aside, I wonder if what part of psychology, which has its flaws as a discipline already, could be mapped or expanded to include AI systems.
That sounds like a dreadful mistake. Just like start over with AI systems. If they're imitating humans who have known psychiatric disorders, then sure, you may be able to predict it. Like if you ask it to behave in a psychotic fashion, and it obligingly does so, then you may be able to predict its responses by using the theory of psychosis. But if you're just, start over with... Yeah, don't drag this psychology.
I just disagree with that. I mean, it's a beautiful idea to start over, but I think fundamentally the system is trained on human data on language from the internet, and it's currently aligned with RLHF, reinforcement learning with human feedback. So humans are constantly in the loop of the training procedure. So it feels like in some fundamental way, it is training what it means to think and speak like a human. So there must be aspects of psychology that are mappable. Just like you said with consciousness, it's part of the text. So
I mean, there's the question of to what extent it is thereby being made more human-like versus to what extent an alien actress is learning to play human characters.
I thought that's what I'm constantly trying to do when I interact with other humans, is trying to fit in, trying to play a robot, trying to play human characters. So I don't know how much of human interaction is trying to play a character versus being who you are. I don't really know what it means to be a social human.
I do think that those people who go through their whole lives wearing masks and never take it off because they don't know the internal mental motion for taking it off, or think that the mask that they wear just is themselves, I think those people are closer to the masks that they wear than an alien from another planet would, like learning how to predict the next word that every kind of human on the internet says.
Mask is an interesting word. But if you're always wearing a mask in public and in private, aren't you the mask?
I mean, I think that you are more than the mask. I think the mask is a slice through you. It may even be the slice that's in charge of you.
Yeah.
But if your self-image is of somebody who never gets angry or something, and yet your voice starts to tremble under certain circumstances, there's a thing that's inside you that the mask says isn't there. And that, like, even the mask you wear internally is like telling inside your own stream of consciousness is not there, and yet it is there.
It's a perturbation on this slice through you. How beautifully did you put it? It's a slice through you. It may even be a slice that controls you. I'm going to think about that for a while. I mean, I personally, I try to be really good to other human beings. I try to put love out there. I try to be the exact same person in public as I am in private. But it's a set of principles I operate under. I have a temper. I have an ego. I have flaws. How much of the subconscious am I aware? How much am I existing in this slice? And how much of that is who I am? In this context of AI, the thing I present to the world and to myself in the private of my own mind when I look in the mirror, how much is that who I am? Similar with AI, the thing it presents in conversation, how much is that who it is? Because to me, if it sounds human, and it always sounds human, it awfully starts to become something like human. No?
Unless there's an alien actress who is learning how to sound human and is getting good at it.
Boy, to you, that's a fundamental difference. That's a really deeply important difference. If it looks the same, if it quacks like a duck, if it does all duck-like things, but it's an alien actress underneath, that's fundamentally different.
If, in fact, there's a whole bunch of thought going on in there, which is very unlike human thought and is directed around like, okay, what would a human do over here? And, well, first of all, I think it matters because there's, like insides are real and do not match outsides. Like the inside of a brick is not like a hollow shell containing only its surface. Mm-hmm. There's an inside of the brick. Yeah. If you like put it into an X-ray machine, you can see the inside of the brick. And just because we cannot understand what's going on inside GPT does not mean that it is not there. A blank map does not correspond to a blank territory. I think it is like predictable with near certainty that if we knew what was going on inside GPT, or let's say GPT-3 or even like GPT-2 to take one of the systems that like has actually been open sourced by this point, if I recall correctly. Like, if we knew what was actually going on there is no doubt in my mind that there are some things it's doing that are not exactly what a human does. If you train a thing that is not architected like a human to predict the next output that anybody on the internet would make, this does not get you this agglomeration of all the people on the internet that like rotates the person you're looking for into place and then simulates that and then like simulates the internal processes of that person one to one. It is to some degree an alien actress. It cannot possibly just be like a bunch of different people in there, exactly like the people. But how much of it is like how much of it is by gradient descent getting optimized to perform similar thoughts as humans think in order to predict human outputs versus being optimized to carefully consider how to play a role, how humans work, predict the actress, the predictor, that in a different way than humans do. Well, that's the kind of question that with like 30 years of work by half the planet's physicists, we can maybe start to answer.
You think so? So I think that's that difficult. So to get to, I think you just gave it as an example that a strong AGI could be fundamentally different from a weak AGI because there now could be an alien actress in there that's manipulating.
Well, there's a difference. So I think like even GPT-2 probably has like very stupid fragments of alien actress in it. There's a difference between like the notion that the actress is somehow manipulative. Like for example, GPT-3, I'm guessing to whatever extent there's an alien actress in there versus like something that mistakenly believes it's a human, as it were. Well, maybe not even being a person. So like the question of like prediction via alien actress cogitating versus prediction via being isomorphic to the thing predicted is a spectrum. And even to whatever extent it's an alien actress, I'm not sure that there's like a whole person alien actress with like different goals from predicting the next step, being manipulative or anything like that. But that might be GPT-5 or GPT-6 even.
But that's the strong AGI you're concerned about. As an example, you're providing why we can't do research on AI alignment effectively on GPT-4 that would apply to GPT-6.
It's one of a bunch of things that change at different points. I'm trying to get out ahead of the curve here, but if you imagine what the textbook from the future would say, if we'd actually been able to study this for 50 years without killing ourselves and without transcending, then you like just imagine like a wormhole opens and a textbook from that impossible world falls out.
Yes.
The textbook is not going to say there is a single sharp threshold where everything changes. It's going to be like, of course, we know that like best practices for aligning these systems must like take into account the following like 7 major thresholds of importance, which are passed at the following 7 different points.
Yeah,
is what the textbook is going to say.
I asked this question of Sam Altman, which if GPT is the thing that unlocks AGI, which version of GPT will be in the textbooks as the fundamental leap? And he said a similar thing, that it just seems to be a very linear thing. I don't think we won't know for a long time what was the big leap.
The textbook isn't going to talk about big leaps, because big leaps are the way you think when you have like a very simple scientific model of what's going on, where it's just like all this stuff is there or all this stuff is not there. Or like there's a single quantity and it's like increasing linearly. It's like the textbook would say like, well, and then GPT-3 had like capability W, X, Y, and GPT-4 had like capability Z1, Z2, and Z3. Like not in terms of what it can externally do, but in terms of like internal machinery that started to be present. It's just because we have no idea of what the internal machinery is that we are not already seeing like chunks of machinery appearing piece by piece, as they no doubt have been. We just don't know what they are.
But don't you think there could be, whether you put in the category of Einstein with theory of relativity, so very concrete models of reality that are considered to be giant leaps in our understanding, or someone like Sigmund Freud, or more kind of mushy theories of the human mind, don't you think we'll have potentially big leaps in understanding of that kind into the depths of these systems?
Sure, but like humans having great leaps in their understanding of the system is a very different concept from the system itself acquiring new chunks of machinery.
So the rate at which it acquires that machinery might accelerate faster than our understanding.
Oh, it's been like vastly exceeding the rate at which it's gaining capabilities is vastly over racing our ability to understand what's going on in there.